diagram. It's not true to life. But what I've drawn here is Bowman's capsule. I've drawn the renal tubule. Here's the PCT. Here's the loop Penley. Here's the DCT. And here's your collecting duct. Did y'all follow that part? Okay. And then the collecting duct is going to carry filtrate into the minor calyx, where it becomes urine. These are two minor calyces. Here's another renal pyramid over here. These two join together to form a major calyx. And this major calyx is draining into the renal pelvis, which then becomes the ureter. Okay. That's kind of the sequence of collecting duct. Now, let's suppose someone develops a stone, a kidney stone that blocks the ureter here. Then what I'm going to tell you is that kidney filtration stops altogether. It stops. At some point, kidney filtration stops. And the reason is this, is that if you have an obstruction, there's going to be a buildup of fluid and pressure behind this obstruction. It's like if you have a crash on the road that's blocking the flow of traffic, cars are going to build up. And as that buildup of cars increases, then it's going to extend backwards. So as pressure builds up behind this obstruction, that pressure then extends backwards from the ureter to the renal pelvis, the major calyx, the minor calyx, and then in the collecting duct. From the collecting duct, that high pressure moves retrograde into the renal tubule, and then finally into Bowman's capsule. So that if you have an obstruction, this capsular hydrostatic pressure, instead of being 15, let's say it increases to 25. Does everyone see how I'm getting there? Okay, so now 25 plus 30 is 55. 25 plus 30 exactly equals the glomerular hydrostatic pressure. So now, if I'm doing the math, 55 minus 55 gives me a net filtration pressure of 0. So that now, in the face of this obstruction, is anything being filtered? No, there's no net pressure pushing fluid across. So filtration stops. Filtration stops. That kidney no longer functions because of the buildup of that opposing force. Okay. So the amount of blood being filtered, what we call the glomerular filtration rate, is dependent upon this net filtration pressure. The higher this net filtration pressure, the more blood gets pushed across, gets filtered, okay, to provide formation of urine. If net filtration falls, then less blood gets filtered, which means that waste products begin to accumulate within the bloodstream. BUN and creatinine begin to climb, which reflects impaired kidney function. Did you follow that?